assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
For this problem, we're told that we have a 5 kilogram object attached to a spring that has a constant of 1,000 newtons per meter, that it's displaced 50 centimeters, and that the initial velocity is 10 meters per second. One of the first things that we are going to want to do is to actually go ahead and change our centimeters here into meters. So this is just 0.50 meters, so that we have everything in meters rather than the 1 in the centimeter. Alright, so our first task we're being asked to do is to figure out what is the frequency of this oscillation. So we're going to use the equation omega equals the square root of the spring constant divided by the mass. So in this case, we're going to find the square root of 1,000 divided by 5, which gives us 14.14. So that is our omega, and omega also equals 2 pi f. So if we substitute in this value here for our omega, we end up with the equation 14.14 equals 2 pi f, and solving for f, we get that f is 2.25 hertz. So that is our frequency of this oscillation. The next thing we're being asked to find is the potential and the kinetic energy. Now for this, we have the equations potential energy equals 1/2 kx squared, where x is the displacement. So when I substitute in my values, I have 1/2 times 1,000 times 0.5 centimeters, because this is 0.5 centimeters, squared, and that gives me a total of 125 joules. Kinetic energy is 1/2 the mass times the velocity squared. So again, I have my mass right here, and I have my initial velocity, so I can substitute those values in, and I have k equals 1/2 5 times 10 squared, which gives me a total of 250 joules. So that is my potential and my kinetic energy. Finally, I'm being asked to find the amplitude of this. And for this one, we're going to use the equation where total energy equals 1/2 your spring constant times your amplitude squared. We have our total energy, which is going to be our kinetic plus our potential, which is 375 joules. So 375 equals 1/2 times 1,000 times our amplitude squared. Or we could say that our amplitude equals the square root of 375 divided by 500, which gives us an amplitude of 0.866 meters, or 86.6 centimeters.